Euclid's Elements, Book 1, Prop 39. Equal triangles which are on the same base and on the same side will also be in the same parallels. So let's start with a base, and let's have two triangles that are equal to each other on this same base. So let's have this triangle, ABC, and let's have an equal triangle on this base. We'll call it CDB. So it's given that these triangles are equal. The triangle ABC is equal to triangle DCB. And what we want to prove is that they are in the same parallels, which means if we draw a line between A and D, which we can do postulate 1, that AD will be parallel to BC. That's what we're trying to prove. So that AD, the line connecting the tops, will be parallel to our base BC. So this is going to be a proof by contradiction. So we're going to make the claim, I say, that AD is parallel to BC. If it's not, so this is my assumption, let's assume for a second that it's not parallel, then that means I can draw another line through A that is parallel to BC. So Prop 31 says I can draw a line parallel to a given line through a given point. So let it be AE. And so now let's connect our points here. And what we can see here is we have another, see if I can make it a different color here. We have another triangle, right? So we have a green triangle kind of inside our blue triangle. All right, here's our blue triangle. A lot of overlapping colors here. Well, if this is now parallel to this, okay, so we're going to draw AE parallel to BC. If that's so, then we have this new triangle in green, triangle EBC, that must be equal to triangle ABC. Put that in red. For they are on the same base and they're now in the same parallel. So this is Prop 37, and Prop 37 says that if you have triangles on the same base and in the same parallels, then they must be equal. So the green triangle is equal here to the red triangle. But we already know as a given that this red triangle is equal to our blue triangle, triangle DCB. This is part of our given. Which means that the green triangle and the blue triangle are equal to each other. But what's the problem with that through common notion 1? Well, the green triangle is clearly inside or part of or less than the blue triangle. So we were saying that the lesser is equal to the greater, which is absurd. It's a violation of common notion 5. The whole is always greater than the part. So the part can't be greater or equal to the whole. So this absurdity occurred when we assumed that AD wasn't the line that was parallel. So we have to give up with that. We say, well, we can't draw it below AD. Now, you could ask yourself, well, what happens if maybe we just picked the wrong side? Maybe we should have drawn it above AD. Maybe we can draw AE instead of down here, where it led to this absurdity. Maybe we could draw it up here. Does that lead to the same absurdity? Well, it does. Because if we draw the line, now by hypothesis or by assumption, we've drawn a new line, AE, that's parallel to BC. And what we can do is we can extend this up here like this. We can connect these points here like this. And now what we're going to prove is that the green triangle is equal to the red triangle through Prop 37. But now the green triangle is the whole and this is the part, and we still have, since the green is equal to the red and the red is equal to the blue, the green is equal to the red, the whole is equal to the part, which is absurd. So whether we draw it above AD or below AD, it leads to the same absurdity. Therefore, there cannot be another line parallel to BC except line AD. Therefore, AD must be parallel to DC. And therefore, my initial claim holds up. Therefore, if equal triangles be on the same base and on the same side, they will be contained by the same parallels. And since we've proved that, we conclude QED.